This video is on the objective, write a polar equation in Cartesian form. So in this objective we are given an equation in terms of r's and thetas, polar coordinates, and we're going to convert it to an equation with x's and y's, right? Rectangular coordinates or Cartesian coordinates. And these equations are going to be such that if you were to, graph the points that satisfy the polar equation on a polar grid, and if you were to graph the points that the coordinates that satisfy the equation of the Cartesian equation on the xy coordinate plane, those graphs would look exactly the same. Right? They'd actually trace out the same curve, the same exact locations. All right. So again, if you want to see more about the topic, look at more instruction, look at their videos, their notes, their examples. Hopefully those help you. Alright, and I've got some of that here. I'm going to show you some of the instruction that you'll see. So here, identify and graph polar equations by converting to rectangular equations. So polar equations and rectangular equations, while they are graphed on different grids, still produce identical graphs. These following examples will demonstrate this. Alright, so I'm going to read a couple of these to you just to give you an idea as to what's going on. So here is, convert the polar equation, r equals 2 times the secant of theta, the r's and thetas, to a rectangular equation, and draw its corresponding graph. So remember, r equals 2 secant theta. That's 2 divided by cosine theta. Then multiplying by cosine theta on both sides gives me r cosine theta equals 2. And hopefully this looks like familiar, right? R times the cosine of theta in rectangular coordinates is x. And that's what we're trying to get. We're trying to get r cosine thetas to show up so I can change them into x. And we're trying to get r sine thetas to show up so I can change them into y. Or get r squareds to show up so I can change them into x squared plus y squared. Or get the tangent of theta to show up so I can change it to y over x. Right? Remember all those relationships between the coordinates in rectangular and the coordinates in polar. Now x equals 2, the graph of x equals 2 on the coordinate plane for rectangular coordinates, Cartesian coordinates, that's just a vertical line, right? X equals 2. And if you were to graph all the points, r's and thetas, that satisfy this equation on the polar grid, all those points would also form the same vertical line. So these are equivalent equations, one in rectangular and one in polar, one with x's and y's, ones with r's and thetas. Right. And here's another example. Now here, in order to get all the r sine theta, r cosine theta, I'd have to multiply this side by r. And if I multiply this side by r, I'd multiply the other side by r. And that'd give me r squared on the left, and 4r sine theta, 8r cosine theta. That'd be 4y plus 8x. X squared plus y squared equals 8x plus 4y. 4y plus 8x. There you go. And they both have equations, they both have graphs that are circles. Now they don't write that here, but you could see it on the Desmos website, right? This is desmos.com, D-E-S-M-O-S. It's a free online graphing calculator where you can graph equations in rectangular, just typing with x's and y's. So like x squared plus y squared equals, what was that, 8x plus 4y. See, there's this circle on the coordinate plane. But you can also graph in polar, and when you type, with r's and thetas, it'll graph it as if it were drawing on the polar grid, even though you're not seeing a polar grid. So here was what it was: r equals 8. I would need 8 cosine theta, and you can just type the word theta, and the symbol theta will come in, theta. plus 4 sine theta, and there you go. And you see it's, and then I'll have, look at the graphs. There, the green graph was the graph in rectangular, and the purple graph right on top of it, the same exact curve in polar. And that's what we're trying to do. We're trying to write equivalent equations that have the same graphs. Right? They trace out the same exact locations. All right, so here I am given this equation and asked to convert to Cartesian coordinates, right? Convert it to an xy equation. All right, so let me write this out on paper. So we have r equals 7 times the sine of theta divided by, and then cosine theta squared, or 5 times cosine squared theta. Okay. So here's one thing I'm noticing. If I just multiply by cosine, okay, if I just multiply by cosine, so times cosine theta on the right side times cosine theta on the left side. On the left side, I will have this, r times cosine theta, and on the right side, one of these cosines will cancel, and I'll have 7/5, right, 7 over 5, times, you have sine theta over cosine theta. That is tangent theta, right? Because again, one of the cosines would cancel. So these are the same equation. And remember, I'm trying to keep in mind these relationships. Right? These are the 4 relationships between rectangular coordinates and polar coordinates, x's and y's and r's and thetas. I'm trying to have an r squared show up so I can replace it with x squared plus y squared, or I'm trying to have r cosine theta show up so I can replace it with x, or have r sine theta show up so I can replace it with y, or have the tangent of theta show up so I can replace it with y over x, or the cotangent of theta would be x over y. You could do that as well. Well, look at this. R cosine theta, that's in rectangular, x equals 7/5 times, and the tangent of theta is y over x. And then I could, multiply both sides by x. Now, if you want to solve for y, in some of these options, I'm noticing they're solving for y. Multiply by 5x, get 5x squared over here, and then divide by 7. So we're getting a graph of a parabola. Remember, this would be a parabola with a 0, 0 as the vertex and opening up, right? Be some parabola like that. And let's see. Let me show you. All right, again, let's have the calculator, the online graphing calculator, the Desmos website, do this for us. So I'll go back here. Let's get rid of these graphs. And the first one I'll put in is that polar graph, the polar equation they gave us. R equals, and then the numerator, you had 7 times the sine of theta divided by, and then 5 times the cosine, I'll just do this, cosine of, in parentheses, cosine theta, and then squared. Right. And look at that parabola with a vertex at the origin. And then my rectangular graph, my Cartesian equation was y equals 5/7 x squared. And look, it's right on top of it. It's the exact same curve traced out. Right. Same exact curve. One in rectangular, one in polar, tracing out the same locations on the coordinate plane. And that's this option right here, y equals 5/7 x squared. So it can be a bit tricky. I've got experience. I've practiced this a bunch, so I see things. You're going to need probably to practice this a bunch to see where you can make. Again, I want to try to make as many of these relationships show up as I possibly can. I want to see an r cosine theta sometimes. I want to see an r sine theta. I want to see an r squared or a tangent theta, and that's what I made happen here. All right, that is what I made happen by just simply multiplying by one cosine. You know, not cosine squared, but just multiplying by cosine got me that. All right. So yeah, it can be a bit tricky. You know, it takes some practice. I'll put up another video where I do one more of these, but I'm not going to do too many for you. I want you to do practice some on your own. And yeah, so hopefully watching me go through this. You know, let's see. Yeah, so see, they did it a little differently than I did, but no biggie. Right? You know, they multiplied by 5 cosine squared, then multiply both sides by r, and then change things. Got 5x squared equals 7y, and then divided by 7. Same thing. Okay, same thing. But yeah, so hopefully watching me do this, looking at the more instruction, those examples, their videos, their notes, all that. Reading the answer explanations, you know, seeing how they're doing things. I'm hoping all this stuff helps you when you work on this and practice this material on your own. And thank you for watching.